In this presentation, we're going to talk about the engineering functions. And when we're talking about engineering functions, we're talking about what is it that engineers really do? Well, there are a variety of things that engineers do. They play a significant role in the design and maintenance of our nation's infrastructure, including communication systems, public utilities, and transportations. Engineers continuously develop new advanced materials to make products lighter and stronger for different applications. They are also responsible for finding suitable ways to extract petroleum, natural gas, and raw materials from the earth, and coming up with new ways of increasing crop, fruit, and vegetable yields, along with improving the safety of our food products. So really the question is, what don't engineers do? Engineers are involved in almost every aspect of our everyday, day-to-day life. They are always ensuring the safety and well-being of us and the world around us, basically. So engineers are always working to improve our daily lives as well as existing systems on Earth. So these engineers wind up doing a variety of general tasks. So you can find all the engineering disciplines doing research. This slide defines what is research. Research engineers are generally exploring mathematics, physics, chemistry, and engineering sciences in search of answers or insights that will contribute to the advancement of engineering. A lot of research engineers have a PhD, which means that they've done research along the way to get where they are and have the expertise to continue in that field. Engineers are also involved in development. The development engineer puts his or her skills to the development of products, systems, or processes. The development engineer is instrumental in turning concepts into actual products or applying new knowledge to improve existing products. So getting these products from the lab to the market is one of the integral pieces of what a development engineer does. Once a design is selected, the development engineer oversees its fabrication, usually in the form of a prototype or a model. Then we have design engineers. It's the design engineer that converts concepts and information into detailed plans and specifications that dictate the development and manufacture of a product. We also have test engineers. Test engineers are responsible for developing and conducting tests to verify that a selected design or new product meets all specifications, and those include integrity, reliability, and quality. We have engineers that are involved in business, marketing, and sales. The sales engineer is the liaison person between the company and the customer. It's the sales engineer that must be technically proficient in order to understand the product itself and as well as the customer's needs. We have engineers who work in the field on operations and maintenance. They're constantly involved in maintaining the product at the customer's location. And we have engineers who are involved in management. This is often the president of a technical company who studied engineering and has worked her way up through the line of organization. As an example, Tim Cook, the CEO of Apple, is a trained industrial engineer. We have engineers involved in production, manufacturing, and construction. These engineers are concerned with the performance of actual machines and systems and the processing of raw materials into manufactured products. When we talk about systems in this definition, systems integrate components to produce a functioning product. And when we're talking about manufacturing, these engineers design plants and processes to make products. And the construction engineer in this piece is involved in the building piece of it. And we have quality control and quality assurance engineer. Quality assurance is process-oriented and focuses on eliminating process variation by creating, revising, and strictly implementing a set of tightly and precisely defined processes, procedures, and standards that, when exactly followed, ensure the final quality of a product. Quality control is product-oriented and focuses on testing a sample of a manufacturing process to make sure that it meets the required design specification or quality standards. So that's the difference between quality control and quality assurance. Quality control affects all aspects of engineering, so it affects all of our lives, essentially. For example, chemical engineers may be ensuring that our drinking water is clean. Mechanical engineers ensure that products and structures don't hurt anybody. Civil engineers use a number of common quality improvement techniques to safeguard our roads and cities. Before construction can begin on a new road, soil analysis determines if the land will support it. So quality controls save lives, and it also saves money and time. It's a constant process. Safety. Engineers are responsible for safety, and in fact, the National Society of Professional Engineering Code of Ethics clearly states as its first fundamental canon that engineers in the fulfillment of their professional duties shall hold paramount the safety, health, and welfare of the public. Safety engineers are sometimes referred to as health and safety engineers. They ensure that job sites are hazard-free and that employers provide optimal working conditions for employees. These professionals also ensure that buildings or products comply with health and safety regulations and examine safety programs. So what do engineers really do? Really, the question is, what don't they do? Engineers do all of the things we've said before in this presentation, and all the different disciplines of engineers have engineers serving in these various functions. Furthermore, engineers go into law, education, medicine, and business. So there really isn't anything that engineers can't do.